equation is used for determining crystal structure. W.L. Bragg and W.H. Bragg derived a mathematical relation to determine interatomic distances from X-ray diffraction patterns. The scattering of X-rays by crystals could be considered as reflection from successive planes of atoms in the crystals. However, unlike reflection of ordinary light, the reflection of X-rays can take place only at certain angles which are determined by the wavelength of the X-rays and the distance between the planes in the crystal. The fundamental equation which gives a simple relation between the wavelength of X-rays, the interplanar distance in the crystal, and the angle of reflection is known as Bragg's equation. Bragg's equation is n lambda is equal to 2d sin theta, where n is the order of reflection, lambda is the wavelength of X-rays, d is the interplanar distance in the crystal, theta is the angle of reflection. If we use X-rays of known wavelength lambda, then the interatomic distance d in an unknown crystal can be calculated. On the other hand, if we use a crystal whose interatomic distance d is known, then the wavelength of X-rays can be calculated. The Bragg's equation gives the essential condition for diffraction to occur. When the experiment is done, there will be a maximum reflection at a particular angle theta. That angle is noted. It corresponds to first order reflection n is equal to 1. If the angle theta is increased, maximum reflection occurs at some other higher angle. It corresponds to second order reflection n is equal to 2. Similarly, third, fourth and higher order of reflection occur at certain specific angles. The values of angles obtained are in accordance with the Bragg's equation. Hence, Bragg's equation is experimentally verified. Explain the nature of glass. Ordinary glass is a transparent amorphous substance. It is not a true solid. It is essentially a solution of silica in a mixture of other silicates which has not crystallized on cooling. Glass has no definite melting point. It softens when heated at a certain temperature. With the further rise in temperature, it becomes less and less viscous till at a certain point. It flows freely and is recognizable as liquid. At this stage, the glass can be blown in a mold into desired shape which retains on cooling. The chief characteristic of a glass are hardness, rigidity and ability to withstand shearing stresses, which are all properties of the solid state. On the other hand, glasses are optically isotropic and on heating without any sharp transition passes into a mobile liquid. At a high temperature, glasses undergo phase transition when crystals separate first as they do form supercooled liquid. Therefore, glasses are regarded as amorphous solids or supercooled liquids as well. Thus, glass or vitreous state is a condition in which certain substance can exist, lying between the solid and liquid state.
Please subscribe our channel for more videos and educational contents.